Okay, so we're going to talk about some projectile motion questions. We're going to be finding the average velocity. So an average velocity would look on a graph more like this. From here to this point, what was the average velocity? Versus instantaneous velocity would be specifically where you're at one point, what's your velocity? So you can see here that we could do our y2 minus y1, our slope, right? Our basic slope equation. Versus here, right, we can't do a slope because we don't have two different points. So here we're actually going to have to take the derivative. Okay, height of an object is given by this formula. H is in meters, t is in seconds. Find the average velocity from time is 1 to time is 3. So you're going to have to insert a 1. So when you insert a 1, so when input 1, your output is 98. And you're also going to have to input a 3. So when you input a 3, your output is 254. Okay, so now we can do our y2 minus y1. y2 minus y1. So then this would be x2 and x1. Okay, so if I divide 156 by 2, I get 78 meters per second. Okay, estimate the instantaneous velocity. So this says estimate. Okay, so I'm going to use two different values. I'm going to use at time is 2.9 and at time is 30.1. Okay, so I'm going to input 2.9. So I get a value, an output of 247.2, and I'm also going to do the same inputting a 3.1, and I get 260.7 as my output. Okay, so if I do an estimation, y2 minus y1 over x2 minus x1, and that comes out to 67.5 meters per second.
I can do this.
So the difference between this question and this is estimating versus find the instantaneous. So in order to find the instantaneous velocity, I have to derive this. So h prime, so I have to derive this. So times is negative 10 t, and then if I derive this one, I get 98, and then obviously t to 0, and then if I derive that, it's 0. So now when t is 3, I input the 3, so negative 30 plus 98 is 68 meters per second. Okay, so you can see that kind of like our theory of limits, as you get closer, like these points get closer together than these points are closer together than those points, so obviously this is going to be a better estimate than that one.
The last one.
Okay, one more question. Okay, same idea. Find the average velocity from 2 to 4. So input a 2. So when you input a 2 into the equation, everybody knows how to do that. You just plug it in. Negative 5, 2 squared plus 60 times 2. So your output is 200. And when you input a 4, you get out a 260. So y2 minus y1 over x2 minus x1. So you get 30 meters per second. Okay, Find the instantaneous velocity. Find the instantaneous velocity at 4. So now we have to derive because it says instantaneous. Okay, so when we derive our equation, we get negative 10t plus 60, and then that's 0. So at time is 4, so now I need to input a 4, so that equals 20 meters per second.
I don't even know how to do this.
Okay, find when the object reaches a max. So if your object, if you think about this, I know this equation is a parabola and it's a negative, so it's right, the object gets shot in the air and it reaches a max and then it starts to fall. Okay, so when does it hit a max? Right here. So if I think about the tangent line right there, what's the slope of that line? The slope is 0. Okay, so I want to know when the slope is 0. So the slope equation, right, I got from here. So this was the slope equation, and I want to figure out when is it equal to 0. So now I'm just going to do algebra here, move, divide. So at 6 seconds, it will reach a max height. What is the max height? So now I'm plugging 6 in, but I'm not going to plug 6 into this equation, right? Because this gives me my slope. I want to know height, so I go all the way back up here and plug 6 into this. So the height, I'm plugging 6 into the height equation, not the slope equation. And I get 280.